So reinforced concrete design is, it's clear from its name, the design of buildings made up of reinforced concrete material. And what is reinforced concrete material? Concrete which is reinforced with steel bars is known as reinforced concrete material. And steel is normally provided for taking the tensile stresses in the structural components. Okay. Because you know that concrete is very good in compression from your concrete technology, you know this fact, and it is weak in tension. So in those regions where there will be tensile stresses under the given loading, the steel will be provided to enhance the overall capacity of reinforced concrete section. This is the grading policy, midterm and sessional marks, they are 20%, and final term has weightage of 60%. So all the previous version of lectures will be available on this website. You can download those lectures from the website. However, since we update every year the lectures, so the updated lecture will be uploaded on the end of each week. Clear? This is lecture 1, which is basically introduction to reinforced concrete design. The topics covered in this lecture are a general discussion on reinforced concrete design. Then, since the reinforced concrete is made up of concrete and steel, so you should know the properties of concrete and properties of steel. Then for the design, you need also codes. And since it is the reinforced concrete material, so ACI code, especially we will discuss. And then, of course, to calculate the stresses or demands on a reinforced concrete structural component, we need understanding of the mechanics of reinforced concrete material. These are the objectives of the lecture. Now, objective of the course. Humans need construction of civil structures, which includes buildings, bridges, and dams, etc., to fulfill their various needs. So buildings, bridges are provided to connect 2 points. Dams, they are built for storing the water for irrigation purpose or for generating the electricity. So for various needs, these different structures are built. Now, an engineering design of these structures would ensure that these structures are built safe and economical. This is important. Engineering, what is engineering design? Anyone can design, for example, a structure haphazardly, but what should be engineering design? Engineering design would ensure that these structures are built safe and economical. So you can see the safety and economy, they are opposite to each other. If the building is very safe, so it will be uneconomical. If you are going to economize the building, so you will compromise, of course, the safety of the building. So you will proportion the structural members of the building such that it should be safe and at the same time it should be economical. The conclusion is that we should provide a certain factor of safety in the design of structural components. Now, materials such as stones, bricks, timber, steel, and concrete are generally used to construct these structures. So these structures can be made up of these different materials. However, in this course, we will study some basic concepts of the design of buildings. So bridges and dams will not be discussed. We are narrowing the scope of this subject. So bridges and dams, they are not included in the they are out of the scope of this lecture, this course. We will study basic concept of the design of building, and which is made up of reinforced concrete material. The concrete in which steel is used, reinforced concrete. What is reinforced concrete material? आप लोगों को आवाज आ रही है?
Yes, sir.
Yes, sir.
Yes, sir. Now, what is reinforced concrete material? So very simple, the concrete in which steel is used as reinforcement for enhancing primarily the tensile strength of concrete members. So primarily, the tensile strength of concrete is improved by providing steel reinforcement. Clear? Sometimes the steel is also provided in a pure compression member to enhance the compression capacity of the member. Like for example, a column subjected to uniaxial load only. In that case, the steel in the column is provided to enhance the compression capacity of the column. But primarily in a reinforced concrete building, the steels are provided in different structural components to enhance the tensile capacity of the member. So for example, if there is a beam, normally what happens, there is a simply supported beam and it is subjected to transverse loading. So from mechanics, you know that there will be compressive stresses in the top and tensile stresses in the bottom. Okay. Now when the tensile stresses exceeds the tensile strength of concrete, so what will happen? Cracks will appear in the bottom. Clear? And if the reinforcement is not provided in the beam, then there will be abrupt failure of the given beam, a brittle failure. So what we do normally, we provide steel reinforcement in the bottom of beam. So after the crack, the reinforcement will be activated, and through bond, it will provide a composite action to resist the given loading, such that the compressive stresses will be taken by the concrete in the upper part, and the tensile stresses will be taken by the steel in the lower part. So after the cracking, the stress distribution will be like this. In the upper part, the compressive stress will be taken by the concrete, and in the lower part, all the tensile stresses will be taken by the steel. Clear? आवाज आ रही है?
Yes, sir.
Yes, sir.
This is a video आप इसको ज़रा गौर से देखें, which shows uh, the construction of different structural components of a building. How different structural components of a building are constructed. First of all, the construction of footing, excavation of footing, then PCC, then reinforcement of footing and dowels for the column, concrete pouring, and lapping of the column reinforcement with the dowels, then pouring of concrete in the column, then there will be farm work for the floor, this is the farm work for slab and beam, reinforcement of beams and slab you can see here, and then pouring of concrete, lapping of the column, the second story column reinforcement, and pouring of concrete, so this is how a reinforced concrete building is built actually in the field. Now close-up views of different steps. This is excavation, then PCC, reinforcement of column and reinforcement of footing, and dowels for the column. Lapping, you can see the column reinforcement is lapped with this one. This is farm work for the column. You can see longitudinal reinforcement and stirrups in the columns, ties in the column. Similarly, reinforcement in the beam. Reinforcing details of different structural components. Paired reinforcing, that is foundation reinforcement, you can see here. Since it is an isolated footing, so only one layer in the bottom is provided. And column reinforcement dowels, these are called dowels. They are provided when the footing reinforcement. This is beam column connection, the corner beam column connection. You can see here the column reinforcement the beam reinforcement is developed or hooked within the column reinforcement. The connection, beam column connection at first floor, you can see here, this is an exterior connection. Again, you can see the column, the beam reinforcement is passed through the column. Interior connection at the first floor. This is an interior connection. For the design of these connections, there is a separate code, ACI 352 is a code in which is basically covering the design of these connections. Design of interior connection, exterior connection, and corner connection. This is connection at the top floor. There is a mistake in this. There is a mistake here because the beam reinforcement here, it should be continued up to the far face of the column here for proper connection. Okay, this is a video, just it's for demonstration purpose. बिल्कुल आज यहाँ बिल्कुल और बोलो जी सही था ठीक है जब ठीक है सर तो वाला ठीक है Okay, so this is basically a video which shows the construction of different structural components of a building. Clear? So you can see the construction starts from the foundation, then the column is constructed, and then floors. But the design is opposite uh, in this regard, that first of all the floors are designed, then the floor load is transferred to the column, then the columns are designed for the given loading, and the column load is transferred to the foundation, and finally the foundation is designed. So the process of the design and construction process, it goes in opposite ways. Clear? Any question?
No, sir.
If you have any question at any point, you can stop me and you can ask the question. Okay, now based on the load transfer from floor to the foundation, there are basically two types of buildings. One is called frame system, and the other system is called load bearing wall system. So the most common type of building is a frame system, in which the loads from floors are transferred to the foundation through columns. Okay, and in a load bearing wall system, the loads for the floor loads, they are transferred to the foundation through walls. So this is the basic difference between a frame system and a load bearing wall system. In a frame system, the floor loads are transferred through the columns to foundation, and in a load bearing wall system, the floor loads are transferred to the foundation through walls. And a mixed system is a combination of these two systems. For example, in a building, in one part it will be a frame system, in the other part it will be a load bearing wall system. So it is basically a combination of these two systems. So that is why it is called a mixed system. Now, if the floor consists of slab and beam, then the load transfer will be such that the slab load will be transferred to beams, and from beams the load will be transferred to the columns, and finally from column to foundation. But if there are no beams provided in the floor and the slab is directly resting on column, so there will be direct load transfer from slab to the columns and from columns to the foundation. Such systems are called flat plate or flat slab system. Similarly, in case of load bearing wall system, the floor may consist of slab only, or it may consist of slab and beam. So if it consists of only slab, then the slab load will be transferred directly to the walls, and from wall to the foundation. But if it consists of, the floor consists of slab and beam, so then the slab load will be first transferred to the beams, and from beams the load will be transferred to the walls. This is a simple single story, single bay reinforced concrete frame system. You can see here it consists of, the floor consists of slab and beam. So the load of slab, you can see, will be transferred like this from slab to the beam, and then from beam the load will be transferred to the columns, and from column to the foundation. So in a frame system, basically the load of slab will be transferred from slab to the beam, from beam to columns, and from column to the foundation. The reinforced concrete design is carried out component by component, such that slabs, beams, and columns are separately designed. What does it mean? It means that first of all, you will design the slab, okay, for the given demand, for the given loading. Then the load of slab will be transferred to the beams, and for that loading, the beams will be designed, and then the load of beams will be transferred to the columns, and for that load or for that demand, the columns will be designed, and finally the load of column will be transferred to the foundation. Okay, for which the foundation will be designed. So the design will be carried out component by component like this. In load bearing wall system, as I told you, the load from roof, slab are directly transmitted to foundation through walls. So the basic difference between load bearing wall system and frame system is that the floor loads are transferred to the foundation through walls in this case, and in case of frame system, the floor loads are transferred to the foundation through columns. This is a load bearing wall system, you can see here. You can see the floor load, they are transferred to the foundation through walls. Now this is a mixed system, you can see. This part of the building, this is basically a load bearing wall system, and the right portion of the building, it is a frame system. So in case of load bearing wall system, the loads are basically called load bearing walls because they are taking the gravity loads. However, in case of a frame system, the provided walls, they are called infill walls. Clear? Because these walls, because you know that the floor load, they will be transferred through these columns. So the wall will not take the gravity load. So they are called infill walls. They will not take the gravity load. They are not load bearing walls. And they are provided just for partitions. However, these walls, they don't take part in taking the gravity loads, but they will basically contribute to the lateral strength and stiffness of the building when subjected to lateral loading, like for example earthquake loading or wind loading. So in that case, they will basically provide substantial lateral strength and stiffness to the building. And they can be normally they are ignored by the designer. However, they can be modeled through compression struts in the software. Now, whatever the load or demand is on the building, whether it is gravity loading, earthquake loading, or snow loading, it will basically produce four types of load effects or stresses. Load effects or stresses, they are same thing. So the loads will basically produce stresses in the structural members, which are of four types basically. So the load effects may be axial load effects, which is further divided into compressive and tensile stresses. The compressive stresses, they are indicated by shortening of the member. Shortening of the member basically indicate the compressive stresses, and elongation of members, they indicate the tensile stresses. Or for example, in case of reinforced concrete material, cracking of reinforced concrete material, it represents the tensile stresses. So elongation in case of steel structure, or cracking in case of reinforced concrete structure, it represents the tensile stresses in that part of the structural component. Flexure stresses, if there are compressive as well as tensile stresses at the same section under the given loading, then those stresses, they are called flexure stresses. Like for example, in case of simply supported beam, you know that for example this is a simply supported beam, and if it is subjected to transverse loading, there will be compressive stresses in the top and tensile stresses in the bottom. So you can see at the given section there are compressive stresses in the top and tensile stresses in the bottom. Okay, so these such type of stresses, they are known as flexure stresses. Clear? When there are compressive as well as tensile stresses at the same section. Normally, the axial stresses and flexure stresses, they are considered as one set for the design, which means that we will design and proportion the structural components combinedly for these actions, for axial and flexure action. And the shear and torsion, they are considered as another set for the design. So the structural components are designed for shear and torsion combinedly. And now it is assumed that these will not affect the design of each other. So for example, the flexure design will not affect the shear design, and the shear design of structural component will not affect the flexure design of the structural component. Shear stresses, you know this, the sliding of one section past the other is known as shear stresses, and torsion is basically twisting of the structural components about its own axis. Clear? समझ आ रही है बात?
Yes, sir.
Yes, sir.
Yes, sir.
This is a frame which is subjected to gravity loading. You can see the animation of the frame. This is basically the deformation of frame subjected to gravity loading. This is the close-up view of the frame. Now you can see here, if you closely see these small elements, the beam is basically made up of these small elements. So you can see at the end, if you see this element, it is contracted in the bottom and elongated in the top. What does it mean? It means that there will be tensile stresses in the top and compressive stress in the bottom. Clear?
Yes, sir.
Similarly, if you see in the center, this, if you take this element, you can see the element is elongated in the bottom and contracted in the top, which means that there will be compressive stresses in the top and tensile stresses in the bottom. Since it is not a simply supported beam, so therefore there will be negative moment at the end, and that is why the tensile stresses will be in the top at the support. Clear? In case of simply supported, you know that there will be compressive stress in the top and tensile stress in the bottom, at the center as well as at the support. However, in case of these beams, which are not basically simply supported on the support, there'll be negative moment at the supports, and that is why, due to negative moment, there will be tensile stress in the top and compressive stresses in the bottom.
सर ये सिंपल सपोर्टेड और ये जो आपने बताया इसमें किस तरह फर्क करेंगे सर?
Simply supported, for example, a beam is resting on walls. This is a beam. It is resting on the walls on both sides. So since there is no monolithic connection of the wall with the beam, the reinforcement of beam is not continued into the wall. So this is a simple connection. The beam is just resting on the wall. There is no connection of beam with the wall. Clear? So this is called a simply supported beam. But if the beam is developed into a column, so which means that the reinforcement of beam will be developed within the column. Clear? So in this case, this is not a simple connection. This is a monolithic connection. The forces of beam will be transferred. The moment of beam will be transferred to the column through this connection. Clear? So there will be moment transferred between the beam and column, and that is why it's not a simply supported connection. It is not a simply supports. This is basically a fixed connection. समझ आ रही?
Yes sir.
So basically, this simply supported beam, this is basically idealization. We idealize the beam such that, and this idealization is made based on the behavior of a beam when it is supported on the walls. For example, what if we remove this support? अगर हम इस सपोर्ट को हटाएं तो क्या होगा?
गिर जाएगा बीम.
गिर जाएगा ना? It will rotate. And what if this wall is removed? What will happen to this beam practically?
सर ये भी रोटेट हो जाएगा.
So based on this behavior, we can idealize these supports as hinge supports. Clear? This is not these hinges are not basically provided practically. This is just idealization, which means that if the beam is simply resting on the wall, so it can be idealized that there are hinge supports at the ends of the beam. Clear?
Yes, sir.
और ये आइडियलाइजेशन आर्बिट्री नहीं है, haphazard नहीं है. It is based on the true behavior of the beam. So this idealization must closely reflect the actual behavior of the beams. Clear?
Yes, sir.
Now there's a simple animation which shows these different types of load effects. This is basically compressive stresses. You can see the shortening of the member and increase in the cross section of member at the midspan due to Poisson effect. The same member is subjected to tensile stresses. You can see elongation of the member and decrease in the cross section due to Poisson effect. These are the flexure stresses. Torsional stresses, which is basically twisting of the member about its own axis. These are the shear stresses. You can see sliding of one part. So now I hope it's clear to you. You have already discussed these things in your mechanics courses.
Sir,
GG.
सर फ्रेम स्ट्रक्चर में तो सर टॉर्शनल स्ट्रेसेस सर कम क्रिएट होंगे आई थिंक.
Yes, there will be torsional stresses normally at in the perimeter beams, but in the other beams there may be torsional stresses. Basically, if there are unequal spans, then even at the interior beams, torsions may be produced. Clear? Especially on the perimeter beam, for example, this is the plane of a building, and these are the beams provided. So there will be moment if we draw the moment diagram. So there will be equal moments on the interior beam. Okay. However, on the exterior beam, there will be moment only along one direction. The moment coming from this span. So it will not be balanced by moment at the right side. So this moment, this will become a torsion on the exterior beam. बात समझ में आ रही है?
जी सर बिल्कुल.
Similarly, the moment coming on this beam will become a torsion on the perimeter beam. क्योंकि यहाँ पर तो ये moments balance हो रहे हैं ना. Moment coming from this span will be balanced by moment coming from this span. But perimeter beam में ये balance नहीं हो रहे. सही?
Yes sir. Okay. Thank you sir.
Now what is structural design? So again, the structure must be designed to withstand all these load effects which we have studied. That is axial load effect, flexure load effect, stresses, shear stresses, and torsion stresses. the design is basically the structural design is the proportion of the members such that it should withstand all these load effects without undesirable consequences. What does it mean? What does it mean by undesirable consequences? So if we design a member, structural member for the ultimate condition, then the undesirable consequence means failure. Clear? So you should design a building such that it should withstand all these load effects without failure for the ultimate condition. And if we design the structural member for the serviceability, so then the undesirable consequence means the visible cracks, excessive deflections in the member, and excessive vibrations in the structural member. So in case of serviceability design, the undesirable consequences means excessive deflection and vibration and visible cracks. And in case of strength design, the undesirable consequence means failure. So conclusion ये है कि undesirable consequence का मतलब strength design में ये कि it should withstand all these load effects without failure. Clear? But in case of serviceability design of the same member, the undesirable consequence means that there should be no visible cracks in the member, there should be no excessive deflection and vibration in the member. Clear?
Yes, sir.
Because even if it doesn't fail, even if a member doesn't fail, but there are excessive vibration or excessive deflection or visible cracks in the member, so it will not be serviceable. Clear?
Yes, sir.
In order to learn the design of reinforced concrete buildings, following must be studied. Properties of concrete and reinforcing steel, because it is made up of concrete and reinforcing steel. Building codes used for design of reinforced concrete, because how much factor of safety should be included in our design? It will come from the codal equations. And of course, mechanics of reinforced concrete should be known to you before the design of building. Clear?
Yes, sir.
So first of all, we will discuss the properties of concrete, and mainly the mechanical properties of concrete. Clear? So the most important property of concrete is its compressive strength. So first of all, we will discuss the compressive strength of concrete. The uniaxial compressive strength is measured by a compression test of a standard test cylinder. This test is used to monitor the concrete strength for quality control or acceptance purpose. So there is a cylinder of 6 by 12 inch, which has 6 inch dia and 12 inch the length of the cylinder, and it is tested in the UTM after 28 days of moist curing. As per the ASTM standards C39 and C31, you can see these documents for the standard test protocol of the test cylinder. Clear? You might have seen the this test in UTM. in material lab.
ठीक है
देखा है ना? आप लोगों ने ये टेस्ट किया है खुद?
यस सर, क्या है बिल्कुल
यस सर, मीन्स डिजाइन होती है।
डिजाइन वाले सिस्टम में वो बनाए थे सर।
अच्छा, किस तरह ये स्ट्रेंथ किस तरह कैलकुलेट करते हैं, कोई बता सकता है?
सर लोड डिवाइड बाय क्रॉस सेक्शनल एरिया।
Load divided by cross sectional area. The
So
maximum
crushing-
load, the maximum load which can be taken by the cylinder without failure divided by cross sectional area. This test is used to monitor the concrete strength for quality control and acceptance purpose. So this is used for the quality control in the field. Clear? For example, आपने concrete strength specify किया है 3000 psi. तो फील्ड में फॉर एग्जांपल साइट में कंक्रीटिंग हो रही है, तो आप उसका एक सैंपल उठाते हैं और यहाँ पर यूटीएम में टेस्ट करते हैं. If the strength is less than 3000 psi, so you can reject the concreting. And if the strength is greater than 3000 psi, so you can approve the concrete working at the site. Clear? It is used for the quality control of concrete work at the site. Clear?
Yes, sir.
और इसकी complete details ASTM standard में given है. And what is ASTM standard? Actually, there are two parts of ASTM, American Society for Testing Material. One is called ASTM standard, and the other part is called ASTM specifications. So in the ASTM specification, what properties we desire from a material, what properties are desired from a material, it is given in ASTM specifications. Clear? And how to achieve those properties, how to ensure that these properties exist in the given material. So for that you have to test that material, and that's the procedure of that test, it is given in the ASTM standard. Clear? So ASTM specification में क्या है? The properties of a material which is desired, and how to ensure that these properties exist in the material. For this you need test, and the procedure for the testing is given in ASTM standards. Clear? Now this is the stress strain curve of a cylinder which is subjected to uniaxial loading. You can see that with the increase in load, the stresses will be increased. There will be maximum stresses at this point. So almost the 0.002 strain, there will be maximum stress or the strain. The maximum stress is also called the maximum stress in a member is known as the strength of that member. Clear? And finally, there will be crushing of concrete at 0.003 strain. Basically, there will be a load deformation curve will be obtained, and from that load deformation curve, you can obtain the stress strain curves. However, you should at least remember this value, crushing strain of the concrete. This is the most important parameter of the concrete, and it will be used in the reinforced concrete design later on. So you should remember this value, crushing strain. What is the crushing strain of a concrete normally? it is 0.003. Clear? And it is for all types of concrete almost. You can see for different, these are the stress strain curves of different of concrete having different strengths. Clear? So almost for all types of concrete, whether it is low strength concrete or high strength concrete, the crushing strain almost remains the same, that is 0.003. So ACI code says that the crushing strain for the concrete shall be taken as 0.003, because practically there will be some variation. The value may be 0.0035, it may be 0.0028. However, for design you need a value, because each time you cannot test the material which will be used in the building. So for design you need a value, and ACI code says that the crushing strain for any strength of concrete shall be taken as 0.003. Clear? आवाज आ रही है आप लोगों को?
Yes, sir.
Yes, sir.
Yes, sir.
So the strain corresponding to maximum stress or corresponding to the strength of concrete is 0.002. ये भी याद रखें, but this parameter is very important, 0.003. This is basically the crushing strain, because we will design the reinforced concrete structural components for the ultimate condition. And the ultimate condition in case of reinforced concrete structural components, it is defined as the stage at which the concrete is crushed. So crushing of concrete basically indicates the ultimate stage for a reinforced concrete structural components. So that is why the crushing strain is very important parameter. So ये आप लोग याद रखें, the crushing strain of concrete, this is 0.003. Clear? Any question? Some codes take this value as 0.0038. However, ACI code take the value of crushing strain as 0.003. So you should remember this value. Clear? This is the stress strain curve of a concrete cylinder tested in UTM. This is the strain frame wound around the test cylinder. You can see the stress strain curve here. This is basically early age strain test. At 4 days, after the 4 days moist covering, the sample is tested. You can see, first of all, it will be linear, but after this point, the slope will change. It gets mild, and then after the failure, there will be degradation in the stress strain curve. Clear? This strain for this specific test, it is 0.0024. You can see here. So almost equal to 0.002. Clear? And if you calculate this value, it will be somewhat 0.003. Now the next property, so the compressive strength is the most important property of concrete, because in reinforced concrete material we assume that the compressive stresses will be taken by the concrete and the tensile stress will be taken by the steel. And that is why the tensile strength of concrete is not that important property, because we assume that tensile stress will be taken by, at ultimate stage, the tensile stress will be taken by the steel. However, for the uncracked conditions, the tensile strength of the concrete is also an important parameter. So normally it varies between 8% to 15% of the compressive. Normally it is taken as the 10% of the compressive strength of concrete. Like for example, there is 3000 psi compressive strength of concrete. So the tensile strength will normally be 300 psi. Clear? Now how to calculate the tensile strength of concrete? So there are two ways to calculate the tensile strength of concrete. One is determining the tensile strength by direct spread tensile strength test, which is given in the relevant code. And you can also calculate the tensile strength of concrete indirectly by flexure test. Clear? Which is also called modulus of rupture or flexure test method.
सर ये 8% और 15% की समझ नहीं आई
8% 15% का मतलब ये कि 8 to 15% ऑफ कंप्रेसिव स्ट्रेंथ इसकी स्ट्रेंथ होगी, यानी या 8% होगी या 9 या 10%, 12% या 15, यानी इसके दरमियान ये वेरी करेगी। बात समझ में आ रही है? आपके पास है 3000 psi कंक्रीट स्ट्रेंथ, तो 0.08 मल्टीप्लाइड बाई 3000, जरा मुझे बताएं। टू 240 psi and 0.15 मल्टीप्लाइड बाई 3000, ये जरा बताएं। ये रेंज है ना, इट इज 450 psi। इसका क्या मतलब? इसका मतलब ये if the compressive strength of the concrete is 3000 psi, then the tensile strength will vary between this will be in this range, and the tensile strength will be either 240 psi or 300 psi, समझ में आ रही बात, और 400 psi और 450, यानी इस रेंज में होगी टेंसाइल स्ट्रेंथ।
सर मतलब टेंसाइल स्ट्रेंथ हमेशा कंप्रेसिव स्ट्रेंथ से कम होगा?
बिल्कुल जाहिर है, ये तो आप लोगों ने नहीं पढ़ा है कंक्रीट टेक्नोलॉजी में। रिइंफोर्समेंट तो तभी हम देते हैं ना, बेसिक फिलॉसफी यही है, सिंस द कंक्रीट इज वेरी वीक इन टेंशन। अब आप देखें ना 8 to 15%, यानी 10% ऑफ द कंप्रेसिव स्ट्रेंथ, यानी आप कंप्रेसिव स्ट्रेंथ को 10 पर अगर डिवाइड करेंगे तो दैट विल बी नॉर्मली इट्स टेंसाइल स्ट्रेंथ, तो काफी कम होता है ना। बात समझ में आ रही है?
यस सर।
Concrete is very good in compression, but it is very weak in tension, and that is why we provide steel reinforcement in those regions where there will be tensile stresses under the given loading. Clear? तभी तो हम reinforcement देते हैं, क्योंकि it is very weak in tension. बात समझ में आ
Yes,
रही
sir.
है? Now how to calculate the tensile strength of concrete? So you can calculate the tensile strength of concrete by flexure test, by conducting flexure test on a beam sample. This is a simply supported beam. A load is applied on the center of this beam. The size of beam, the dimension of beam are given here. This is given in this standard. The cross-section of beam is 6 inch by 6 inch square, and it is 30 inch long. And as per this code, the load is applied on the center of the beam. Now, how to calculate the tensile strength from this test? So this is very simple. You know that under the given loading, कहाँ पर compressive stress होगी? टॉप में कि बॉटम में?
Top, yes, sir.
There will be compressive stresses in the top, and there will be tensile stresses in the bottom. इस तरह है ना?
Yes, sir.
Now, as the load is increased gradually, the stresses will be increased, because you know that these stresses can be calculated using this equation. ये कोई बता सकता है? The flexure stresses, tensile or compressive stresses, they can be calculated from which equation?
MY by I. Yeah, MC. Yes.
My divided by I, or MC divided by I for extreme fiber. Clear? So using this equation, you can calculate the flexure stresses. And this M in this case is equal to, M is the bending moment. So for example, if the loading is P, then for a simply supported beam subjected to point loading at the center, what will be the value of bending moment? Anyone?
Sir, half
Analysis.
P into C.
Half of the load multiply with half of the distance.
हाँ तो वैल्यू बताए ना, सही है, PL/4.
PL by 4, yes, sir.
So you can see that this M is directly proportional to P loading, and the stresses are directly proportional to M. So which means that with increase in the P loading, the stresses will be increased. यहाँ तक clear है?
Yes, sir.
Now, as you increase the loading, the stresses will be increased, and at that point, when the tensile stresses in the bottom, exceeds the tensile strength of concrete, which is denoted by FR, modulus of rupture. When the tensile stresses exceeds the tensile strength of concrete in the bottom, so what will happen? A crack will be produced in the center of the beam. Clear?
Yes, sir.
And there will be abrupt failure of the beam under the given loading. So you can note down that value of P for which this first crack will appear in the bottom of the beam. आप नोट कर सकते हैं ना टेस्ट से? रिस्पॉन्ड करें ना यार.
Yes, sir.
क्लियर? अच्छा, So if you calculate, if you note down that value of P, for which there will be first crack in the bottom, और first crack कब appear होगा? When the tensile stresses just exceeds the tensile strength of the concrete. So इसका क्या मतलब? इसका मतलब ये कि this load is basically corresponding to the tensile strength of concrete. अब समझ में आ रही है कि नहीं?
Yes, sir.
Now you can basically determine this load and put this load value in this equation to get the corresponding moment, and put that moment in this equation to get the tensile strength of concrete. सिंपल है ना? और अगर इसको आप सिंप्लीफाई करें, यहाँ पर अगर हम इसकी वैल्यू पुट करें तो C की वैल्यू भी हम पुट कर सकते हैं. C इज इक्वल टू h/2. आप लोगों को पता है, आप लोग ने ऑलरेडी पढ़ा है. एंड I इज इक्वल टू, I की वैल्यू क्या होगी?
1/12 BHQ.
BH cube divided by 12.
BH cube divided by 12. ये अगर हम यहाँ पर पुट करें इस इक्वेशन में, so then tensile strength of concrete will be equal to M into C, which is h/2, divided by I, which is BH cube by 12. इसको अगर हम सिंप्लीफाई करें, so the tensile strength will be equal to 2 6 are 12, so this is equal to 6M. 1H will be cancelled with this, so 6M divided by BH square. So now you can see this equation, this is developed from the standard MC divided by I equation. Clear? And further, if you replace this M with this value, so then you can also calculate, you can express this in terms of loading. 6 multiplied by PL divided by 4 into BH square. So finally, this is equal to 3/2 into PL divided by BH square. So from this equation directly, L is known to you because the beam is 30 inch long. B and H square are known to you because B and H, they are equal, and they are equal to 6 inches. And you can determine this P value from the test. You can take the value of P corresponding to first crack appearance and put that value in this equation to get the tensile strength of concrete. अब समझ गए?
Yes, sir.
So this is how you can determine the tensile strength of concrete indirectly from the flexure test conducted on a simply supported beam. Any question? There's also another, the same way, the concept is same, but the loading condition is different. There's another ASTM standard, which is basically ASTM C78. In that case, there are two loads applied on the same beam, and these loads are applied at L/3 distance, and that test is known as third point loading. This test which we have studied, this is known as center point loading, and that test is known as third point loading. In that case, there will be only difference in this M value. The remaining equation will be same. In that case, the strength will be also be equal to 6m divided by b square, but m will be equal to, in that case, किस तरह कैलकुलेट करेंगे? This is simply supported beam. Half loading at this side and these are L by 3, L by 3 and L by 3. The support reactions are very simple. They will be equal to P by 2. And how to calculate moment at the center? It will be equal to P by 2 multiplied by L by 2 minus P by 2 multiplied by
L by 3, sir.
sorry L by 3 minus P by 2 multiplied by L by 2 minus L by 3. इस तरह है. This will be equal. This will be the moment at the center. तो ये जरा कैलकुलेट करें कितना आएगा. ये सिंप्लीफाई करें शाबाश.
Sir, PL by 12
PL
by 12.
दोबारा जरा इसको कंफर्म करें. This will be equal to PL divided by 6 minus this will be equal to 6 L by 6, so minus PL by 12.
So minus PL by 12.
माइनस पी बाई 12 मगर इसको सिंप्लीफाई करें ना टोटल 12 2PL minus PL, it will be equal to PL. So PL by 12.
सर PL by 12.
जी PL by 12 आता है ना. तो उस
जी
इक्वेशन
सर.
में जरा पुट करें FR is equal to 6M divided by BH square. Clear? This will be equal to 6M की जगह हम लिखेंगे PL divided by 12.
सर माइनस PL by 12 आता है.
माइनस नहीं आता यार, प्लस आता है. आप लोग मैथमेटिक्स में भी क्यों इतने कमजोर हैं? ये तो सिंपल मैथमेटिक्स है. इसमें कौन सी वैल्यू बड़ी है?
सॉरी सर.
So this will be equal to finally PL divided by 2BH square. Clear? So from this equation you can determine the tensile strength of concrete.
Sir,
And the relevant code for this test is C78. This is called third point loading. और ये जो हमने यहाँ पर पढ़ा, this is called center point loading, in which a single loading acts at the center of the beam. It is covered in ASTM C293. G, any question?
सर कैलकुलेशन प्लीज, वो जो थर्ड पॉइंट के लिए जो कैलकुलेशन किया सर वो
हाँ,
शो
अच्छा.
सर ये L/2 नहीं आता सर.
हाँ, ये L/2 है, बिल्कुल.
प्रीवियस में सर, प्रीवियस कैलकुलेशन में हम L/3 पे किया था कैलकुलेशन सर.
अच्छा, ये दोबारा जरा करें. ये L/2 है. अब दोबारा कैलकुलेशन करें जरा, शाबाश.
PL/6 रहता है.
PL/6. तो अगर उसमें हम पुट करें तो FR is equal to 6M divided by BH square, and if we put here this value, so this will be equal to PL divided by PH square simply. So in case of third point loading, from this equation you can determine the tensile strength of the concrete. Clear?
Yes, sir.
अच्छा, अगर हम टेंसाइल स्ट्रेंथ को रिलेट करें कंप्रेसिव स्ट्रेंथ के साथ, तो then the tensile strength will be proportional to the square root of FC prime. इसके अगर हम एक रिलेशन बनाएं, क्लियर, आप टेंसाइल स्ट्रेंथ ले लें और फिर स्क्वायर रूट कंप्रेसिव स्ट्रेंथ, टेंसाइल स्ट्रेंथ and compressive strength of the square root of compressive strength of concrete. So there will be a direct relation between the tensile strength and square root of FC prime. Clear?
Yes.
So what does it mean? It means that improving the compressive strength will also improve the tensile properties of the concrete. Clear? So that is why I told you that the most important property of concrete is the compressive strength of concrete. All the other properties can be correlated with the compressive strength of the concrete. For example, tensile strength जो हमने calculate किया test से, that is the actual value which you can determine from the test. But empirically, you can also calculate the tensile strength based on the Codel equation, which is basically equal to tensile strength of concrete, or FR, it is equal to 7.5 under root FC prime. This is an empirical equation. From this, you can calculate the tensile strength of concrete. बात समझ में आ रही है? Now you can see that if you know the compressive strength of the concrete, then using this relation you can also calculate the tensile strength of concrete. Similarly, the elastic modulus of concrete can also be determined if the compressive strength of concrete is known from empirical equation, and that empirical equation is basically equal to EC is equal to 57,000 under root FC prime. And remember that whenever the FC prime comes in square root, the unit should be in PSI. ये बात याद रखिए, सही? Whenever the FC prime is in square
Yes,
root, you will always put the units in PSI. Clear? Now from test you can also calculate this elastic modulus, but empirically from this equation you can determine the value. How to calculate this value from test? तो यहाँ पर अगर हम देखें, this is a test. So within this region, for example, so within this linear range, for example, from this point up to this point, you can calculate the stress value divided by this strain value. This will give you the elastic modulus, and stress you can calculate. For example, this value is Fs2 and this value here it is Fs1. Similarly, strain value is 1, and at this point the strain value is E is 2. So Fs2 minus Fs1 divided by E is 2 minus E is 1. This will give you the slope, and this slope is basically shows the material stiffness of the this is basically material stiffness, which is also known as the elastic modulus of a material. Clear?
yes, sir.
तो टेस्ट से अगर आप कैलकुलेट करते हैं, so using this method you can calculate it from a test conducted on the concrete cylinder. However, you can also determine the elastic modulus from this relation, this empirical relation. So if the compressive strength of the concrete is known to you, you can determine the tensile strength as well as the elastic modulus using these empirical relations. Also the shear strength, torsional strength, all other properties can be expressed in terms of the square root of FC prime. G, any question?
सर इसमें जो ये जो दूसरा पॉइंट है, रेशियो ऑफ टेंसाइल स्ट्रेंथ टू कंप्रेसिव स्ट्रेंथ डिक्रीजेस एज द कंप्रेशन स्ट्रेंथ इंक्रीजेस। सर इसका क्या मतलब है सर, ये थोड़ा एक्सप्लेन करें।
ये तो बिल्कुल सिंपल है, टेंसाइल स्ट्रेंथ टू कंप्रेसिव स्ट्रेंथ रेशियो डिक्रीजेस as the compressive strength increases. देखिए ये अगर हम कैलकुलेट करें ना, this is tensile strength, it is proportional to the square root of compressive strength. इस तरह के नहीं, अगर आप इसकी एक ले लें टेंसाइल स्ट्रेंथ डिवाइड बाय कंप्रेसिव स्ट्रेंथ, ये एक रेशो आप ले लें। क्लियर? तो आप यहां पर आप जरा देखिए, इट इज नॉट प्रोपोर्शनल टू दी FC प्राइम, इट इज प्रोपोर्शनल टू दी स्क्वायर रूट ऑफ FC प्राइम। तो इसका क्या मतलब है? इसका मतलब ये कि अगर आपके पास FC prime is for example 3000 psi, so what will be the tensile strength? इस इक्वेशन से जरा कैलकुलेट करें। अच्छा ये जरा कर देता हूं ताकि आपको समझ में आ जाए। If you have FC prime 3000 psi, then tensile strength for 3000 psi will be equal to how much? उस रिलेशन से जरा कैलकुलेट करें ना, 7.5 अंडर रूट सी प्राइम कितना आ रहा है? क्विकली यार, इसमें क्या है? सिंपल मैथमेटिक्स है। 3000 psi इसके रूट ले लें, 7.5 मल्टीप्लाई करें।
Sir, 410.8.
410 clear? अच्छा, now if we take FC prime equal to 5000 psi, अब जरा कैलकुलेट करें।
530, sir.
530 FC prime is equal to 8000, जी
670.
670। अब बिल्कुल सिंपल है। अब इन दोनों का रेशो जरा कैलकुलेट करें, यानी इसके लिए भी रेशो कैलकुलेट करें। क्या मतलब है? 410 डिवाइड बाई 3000, ये कितना होगा?
0.136.
0.136। अच्छा, अब दूसरे के लिए रेशो कैलकुलेट करें। 530 डिवाइड बाई 5000,
0.106.
0.106। अब ये थर्ड के लिए कैलकुलेट करें। 670 डिवाइड बाई 8000,
0.008.
0.008। अब इस स्ट्रेंथ को जरा देखिए। द रेशो ऑफ टेंसाइल स्ट्रेंथ टू कंप्रेसिव स्ट्रेंथ डिक्रीजेस। आप इस रेशो को देखें ना, this ratio is less than this ratio and this ratio is less than this ratio. तो आप देखिए ratio will decrease as the compressive strength increases. आप समझ गए बात को कि नहीं? क्योंकि आप देखिए this is not FR or tensile strength is not proportional to the FC prime. It is proportional to the square root of FC prime. बात समझ में आ रही है?
Yes, sir. Thank you, sir.
Now next, okay, these were some important properties, mechanical properties of concrete. Like for example, the most important is in this is compressive strength of concrete, and from which you can determine all the other properties empirically, and the other properties can also be calculated from the tests. Clear? So some of the properties we discussed. There are some other properties of concrete which you can determine. For example, durability of concrete, porosity of concrete, chemical properties of concrete, microstructures, etc. और ये काफ़ी इंटरेस्टिंग सब्जेक्ट है, इसमें काफ़ी काम हो सकता है. So, but those properties we are not discussing because we need only these properties from the design point of view. So next we will discuss the properties of steel. क्योंकि मैंने आपको पहले भी कहा था कि reinforced concrete is made up of concrete and steel. You should know the properties of concrete as well as the properties of steel. Clear? So first of all, we will discuss the types of steel which is used in the buildings. The deform bar reinforcement, which is the most commonly used type of steel used in the reinforced concrete buildings. Plain reinforcement, these were used previously. Nowadays, these are not common. They are replaced by deform bar reinforcement because the anchorage, the bond strength of deform bar reinforcement is more than the plain reinforcement. Then there are pre-stressing steel. They are basically strands of very high strength. Like for example, deform bar or plain reinforcement, normally they are available in grade 40 and 60. And grade 40 means that it has the specified yield strength of 40 KSI. Grade 60 means specified yield strength of 60 KSI. While the pre-stressing strands normally available, they are of 270 KSI strength. So they are very high strength steel. And then structural steel shapes, which are normally used in the steel trusses or in the construction of steel buildings. So in this, the most common is A36 steel, which has the yield strength of 36 KSI. You might have studied this in your steel structure courses. However, since I
ये डिफॉर्म
जी डिफॉर्म्ड क्या?
ये डिफॉर्म बार रिइंफोर्समेंट की समझ नहीं है सर, ये किस तरह होता है सर?
अच्छा, आगे स्लाइड में अब आप देखेंगे. We will discuss in the next slide only properties of deform bars will be discussed, because as I told you that normally we will be using deform bars in the construction of reinforced concrete building. डिफॉर्म बार का ही मतलब है, आप देखें जरा यहाँ पर, ये आप देख सकते हैं लॉन्गिट्यूडनल डिफॉर्मेशंस as well as transverse deformation as well as longitudinal deformation. अब समझ गए? अच्छा, इसका ये क्या करेगा? The bond strength between concrete or steel will be improved by providing these deformation. समझ में आ रही है कि नहीं?
नो सर.
इसमें क्या आपको मसला क्या है?
एक्सक्यूज मी सर.
जी
सर, ये डिफॉर्म का ये जो बल्किंग आउट एरियाज है ना, इस पे इसका तो ये नहीं, ये मतलब नहीं होगा डिफॉर्म शेप का.
हाँ बिल्कुल बिल्कुल यही है, ये जो बल्जिंग आउट ऑफ दीज
लाइंस एक्सेट्रा.
lines, these the lines which are bulging out, you can see here. अच्छा, आप ये उस तरह डिफॉर्म नहीं है कि इसमें कोई डिफॉर्मेशन हो, ये बेसिकली इस बल्जिंग आउट लाइंस जो है इसको हम डिफॉर्मेशन कहते हैं. क्लियर इन इस टर्मिनोलॉजी में?
सर अभी समझ आएगा.
क्लियर? और उससे आपको बिल्कुल पता है कि इससे फ्रिक्शन बिटवीन द स्टील एंड कंक्रीट विल बी इम्प्रूव्ड. क्लियर? एंड नाउअडेज दीज डिफॉर्म बार्स आर यूज्ड. आप लोगों ने देखी होगी स्टील टेस्ट आप लोगों ने किए?
नो सर, स्टील टेस्ट नहीं किए, लेकिन इस तरह देखे है सर. ये स्टील ये यूज होते हैं कंस्ट्रक्शन में.
नहीं, इंजीनियरिंग मैकेनिक्स में आप लोगों ने स्टील बार टेस्ट नहीं किया? क्या होगा मेरे ख्याल में? टेंसाइल स्ट्रेंथ, हाउ टू कैलकुलेट द टेंसाइल स्ट्रेंथ ऑफ,
ये सर किया
ये सर
है.
टेंसाइल स्ट्रेंथ है.
क्या है ना?
Yes, sir.
जी सर.
So using that test, you can determine the actual tensile yield strength and tensile ultimate strength of the steel. Clear?
Yes, sir.
Now, standard deformed bars, they are basically represented by these letters. Different letters are given. This H basically represent the producing mill. For example, the steel produced by Ittifaq Steel, so there will be I instead of H. 11 shows the bar size. For example, the bar size, for example, there is 11, so it means that it is number 11 bar, which means that the die of the bar will be 11 divided by 8 inches. And S shows the type of steel. For example, if the deformed bar reinforcement is conforming to ASTM A615, then it will be noted by S letter. And if the deformed bar is conforming to ASTM A706, another code, another specification, then instead of S there will be W. Clear? So it shows the type of steel. This letter shows the type of steel, and sometimes there will be a fourth letter which shows the grade of steel. So 60 means grade 60 steel, and if there is 40, so it means that the steel will be grade 40. और grade 40 और grade 60 का क्या मतलब है, मैंने आपको बता दिया. Grade 40 means that it will have the yield strength of 40 KSI, and grade 60 means that it will have the yield strength of 60 KSI. Clear?
Yes, sir.
सर ये जो बार साइज है जिसे हम डायफाइन कहते हैं ना 11/8, ये 8 हर
दो आवाज आ रही है, ये क्या मसला है? 1 by 1 पूछे ना? अच्छा, दोबारा पूछे, शाबाश.
जी सर. सर ये जो बार डाया की आपने बात की है ना, बार साइज फर्ज करें 11/8, ये 8 हर साइज पे डायफाइन करने के लिए हर साइज को 8 पे डिवाइड करेंगे?
बिल्कुल बिल्कुल, हर एक साइज को आप 8 पर डिवाइड करेंगे. बिल्कुल
जी सर.
क्लियर?
सर ये 8 सूत्र के लिए हम यूज करते हैं.
हाँ बिल्कुल, जिसको हम पुष्ट में सूत्र कहते हैं. यानी 11 का मतलब कि इट इज 11 सूत्र. ठीक? Eighth part of the inch is known as सूत्र का ना, पुष्टों में इसको सूत्र कहते हैं. These are different ASTM specification. As I told you, in specification there will be properties of material desired. The desired properties of material will be given in specification. So ASTM A615, it covers deformed carbon steel reinforcing bars that are currently the most widely used type of steel. So normally ASTM A615 bars, they are readily available in the market, and in most of the cases these types of bars are used. Clear? And bars of this type are marked with letter S. However, sometime for special projects you may need ASTM A706, but for this you have to order it specially for the specific project. And these are low alloy steel deformed bars intended for application where controlled tensile properties, restriction on chemical composition to enhance weldability, or both are required. So for special cases, for special projects, you may need such type of bars that are represented by letter W. However, the most common types of bar used in the construction industry, it is ASTM A615. Clear?
Yes, sir.
Now these are the different bars. इसको अगर हम, so at least you should know the area of these bars. Number 3 bar, number 4, number 5, number 6, number 7, and number 8. Number 9, number 10, number 11, number 14 bar are also available, but most commonly used bar are number 3 to number 8. Clear? The die of these bars, very simple. It is 3 by 8 inches. It is 4 by 8. So 4 by 8 means 1/2 inches. This is 5 by 8, 6 by 8 dia, which is 3 by 4 inch, 7 by 8 dia, and 8 by 8, so 1 inch dia. Clear?
Yes, sir.
And you should also remember the cross-sectional area of these bars. ये आपने याद करना होगा. आप खैर कैलकुलेट भी कर सकते हैं. चले आप लोग कैलकुलेट कर रहे हैं. शाबाश. क्रॉस सेक्शनल एरिया ऑफ नंबर 5 बार और नंबर 8 बार, इन दोनों का क्रॉस सेक्शनल एरिया जरा कैलकुलेट करें. किस तरह कैलकुलेट करेंगे?
ID square by 4.
हाँ, इससे जरा कैलकुलेट करें. शाबाश.
Sir,
Quickly,
number
मुझे-
5. Sir, number 5 का 0.306.
0.306, so it will be equal to almost 0.31 inch square. और नंबर 8 बार का
0.785.
0.785, so it is equal to 0.79. It is 0.785, but ये डिफॉर्मेशन वगैरह भी अगर आप इसमें इंक्लूड करें तो it will be equal to 0.79 square. तो बाकी को का तो मुझे याद है डायरेक्टली, और आपको भी याद होना चाहिए. आप कैलकुलेट भी कर सकते हैं. For number 3 bar, the area is 0.11 inch square, 0.1 inch square. Number 4 bar, 0.2 inch square. For number 6 bar, it is 0.44 inch square. And for number 7 bar, it is 0.6 inch square. So you should remember these values at least for from number 3 to number 8 bar. क्योंकि डिजाइन में you will be frequently use these bars. Clear? You can also calculate the weight of these bar per linear foot. किस तरह कैलकुलेट करेंगे? Weight per linear foot of the bars. Anyone? चलिए सिर्फ
D square by 162 sir.
सिर्फ नंबर 5 और नंबर 8 बार के लिए जरा आप कैलकुलेट करें. वेट पर लीनियर फुट. दोबारा जरा बताइए आपने क्या?
सर हम इस फार्मूले से फाइंड आउट कर सकते हैं D square डिवाइड बाय 162.
नहीं, वो तो छोड़े ना आप, यानी वो तो एक आपको गिवन है, आपने सिंप्लीफाई किया है इक्वेशन.
Yes, sir.
ये मगर बेसिकली आप इसको कैलकुलेट किस तरह करेंगे? या अगर मैं आपसे ये पूछूं कि ये जो आपने बताया तो आपने ये किस तरह कैलकुलेट किया? ये तो बिल्कुल सिंपल है ना, क्रॉस सेक्शनल एरिया मल्टीप्लाइड बाय इट्स यूनिट वेट। For example, for number 5 bar, the cross-sectional area is 0.31 inch square. So 0.31 inch square. To convert this inch square into foot square, you have to divide it on 144. So this will be in foot square multiplied by unit weight. What is the unit weight of steel in pound per foot cube? Unit weight of steel in pound per foot cube. आवाज आ रही है?
ये सर
Yes,
आवाज आ रही है
sir.
लेकिन पता नहीं।
हाँ तो क्या है आप बताएं ना शाबाश। It is 490 pound per foot cube. Clear? So this will be cancelled with this one. तो आप जरा अब इसको सिंप्लीफाई करें। What will be the unit weight?
1.05.
1.05 pound per foot. So this is the weight of the steel per linear foot. Clear? Similarly, आप नंबर 8 बार के लिए जरा अब कैलकुलेट करें शाबाश quickly.
So 2.68.
It will be equal to 2.68 pound per foot. Clear? So this will not be required normally in the design. This is just required for the steel quantity calculation. But for the design, you should at least remember, as I told you, these values. Clear? Cross-sectional area of these bars. It is given here in this slide, you can see. You can see here the weight per foot. Now these were the geometric properties. Now the material properties, there is the strength of different deform bars. So the steel is available in these different grades, but the most commonly used grades are grade 40 and grade 60. And I told you that the grade means the specified yield strength, minimum yield strength. So grade 40 means 40 yield strength, 50 means 50 yield strength, and 60 means 60 yield strength.
एक्चुअली सर
जी जी
सर 11 बजे हमारा एक और क्लास है सर, नेक्स्ट क्लास।
अच्छा, तो अब क्या करेंगे? इस लेक्चर को तो कंक्लूड करना है ना। लेट टाइम हम
सर नेक्स्ट क्लास या अरेंज करेंगे ना क्लास को?
नहीं, नेक्स्ट क्लास अरेंज नहीं करते
बाद लेंगे सर।
नहीं
आज
सर आज अरेंज करेंगे या नेक्स्ट क्लास में मतलब एग्जाम करेंगे पूरी तरीके
सर
से
इस तरह कर सकते हैं कि सर आप रिकॉर्डिंग कर ले सर, कंटिन्यू कर ले और हम लीव करें, हम नेक्स्ट क्लास में जाए सर।
नहीं, इस तरह करेंगे कि आज ही बस लेट टाइम में क्लास लेंगे ना।
ये भी ठीक है
सर
सर।
अफ्तारी के बाद ले लेंगे सर,
अफ्तारी के बाद, ठीक है। बस आप इस तरह करें
7 बजे।
कि आप लोग डिसाइड करें टाइमिंग एंड इन्फॉर्म मी थ्रू CR।
सर तरा इफ्तारी के बाद तरा
यस सर, ये ठीक।
ओके सर, विल इन्फॉर्म।
आज ही हम क्लास लेते हैं टू फिनिश दिस लेक्चर। ओके
सर आप अभी डिसाइड कर ले, लोग सर को कुछ क्या बताते हैं, कुछ डिफरेंट टाइम बताते हैं, तो सर अभी आप डिसाइड कर ले सारे अभी क्लास में।
तो अभी बताएं